Hi class, this is Dr. Karsten, and today we are doing lesson 37, and that's from Module 5, Grade 4, EngageNY Math. So in yesterday's lesson, we were multiplying a whole number times a fraction, and in today's lesson, we are going to multiply a whole number times a mixed number. So I know you guys are going to do great. You did great with yesterday's lesson, so let's get started. So for our first problem, let's do 2 times 3 1/5. So remember that when we're multiplying and we see 2 times 3 1/5, another way of saying this is I could say that I have 3 1/5 2 times. So again, I could say that I have 3 1/5 2 times. Let's model this. Let's show this with a tape diagram. So what I'm going to do is I'm going to draw 3 1/5 one time, and then I'm going to draw it again so that I will have drawn it 2 times. So I'm going to go ahead and I'm going to model this. So here we have 3, and now I'm going to draw a 5th. And it's not perfect and it's not exact, but it's good enough. So here I have 3 1/5 one time. And now I'm going to model doing 3 1/5. So I have 3 1/5 another time. And so now what you're seeing is that I have 3 1/5 two times. Here's 3 1/5 one time, and here's 3 1/5 another time. And what I'm hoping is that when you're looking at this, you can say to me, oh, well, this is easy. 2 times 3 1/5, or 3 1/5 two times, is just going to be 3 plus 3, which is 6, and then 1/5 plus 1/5, which is 2/5. So I have 6 and 2/5. Well, can we reorganize this to kind of show what we just did? And we sure can. What I'm going to do is I'm going to go ahead and I'm going to first draw that first 3. And now I'm going to draw the other 3 right next to it. So now our 2 3s are next to each other, and then I'm going to draw my 1/5 here and my other 1/5 here. So now what you can see is that I just kind of reorganized them. And in math, when we do this, when we're multiplying a number times a set of numbers or a grouping of numbers, and you'll understand this more in a second, we can distribute across. We can reorganize things, and we use the distributive property. So let me show you what I mean by that. So if I want to use the distributive property for this problem, let me rewrite this problem for us, give us some room to work with. So again, the original problem is 2 times 3 1/5. So instead of thinking of this as 3 1/5, how about we say that it's 3 plus 1/5? And we're allowed to do this. When you have a mixed number, such as 3 1/5, you are allowed to say that that's 3 plus 1/5. Now, I need to be really clear and show that that is still one whole number put together. You have to make sure that you model that if you're doing multiplication. Otherwise, things could go very, very wrong. So to show that this is 3 1/5, that this was one whole number, and that this should really be added together before any multiplication happens, I need to model it this way. But now, if I don't want to add it back together, I can use the distributive property. Now remember, when you distribute something, it means like passing out. In a classroom, the paper distributor job is the person who passes out papers to everyone. They distribute one item to the whole class, across the entire class. Well, in the distributive property, we basically do the same thing. And so what we do is we take this 2 and we're going to distribute it over across to the 3 and then over to the 1/5 by multiplying 2 times 3 and then 2 times 1/5. When we do that, we still hold on to our plus. So my new problem is going to look like this. I'm going to take my 2, I'm going to say 2 times 3 plus, that plus goes right here, 2 times 1/5. And you still really want to show what goes together by using your parentheses. And that's really important when you're doing the distributive property. So again, what I'm showing here is that I could pull apart 3 1/5 into 3 plus 1/5, and then I can multiply each of those times 2. So instead of having to multiply the whole thing together, I can just multiply each of them times 2. So here I'm going to do 2 times 3, which is 6. And then here I'm going to do 2 times 1/5, which we know from yesterday's lesson is I could just say 2 times 1, and I'm going to do this on the side just to remind you. So we have 2 times 1/5. And the way that we thought about this was that that was equal to 2 times 1 divided by 5. Oh my goodness, sorry, the puppy's being very noisy. All right, and so I'm going to go ahead and rewrite that way. So we could say that this is 2 times 1 over 5. So we'd have 6 plus, and here we get 2 times 1 is 2 fifths. And now we want to put those back together. So we'd end up with 6 and 2 fifths. All right, so I hope that that's making sense for you. I hope that you remember what we could do here. Another way that we talked about this, and I just want to remind you of that also. So you could kind of do it this way, and then we can do it another way. And the other way that we could do it is when we saw 2 times 1/5, I'm going to go ahead and rewrite that, is that you could remember that this is the same thing as saying 2 wholes. Remember, the denominator tells us the number of pieces that make up 1 whole. Well, when you have 2 wholes, they're both wholes, so the number of pieces that there are is 1 whole piece. The wholes have not been divided up, partitioned, or cut up in any way, so they're wholes. When you have wholes, put it over 1. And then we're times 1/5. And in multiplication of fractions, you can just multiply your numerators together and then multiply your denominators together. So 2 times 1 is 2, and 1 times 5 is 5. I may have to confiscate that toy from the puppy. We'll see how it goes. Sorry, guys. Okay, so, and I'm going to be modeling both these ways on the side for the rest of the problems because I really want you to figure out what works best for you. All right, so let's try another problem together. And we're going to do a few problems together. I just realized I don't think I gave you a code yet. So let me give you a code. So our first word is going to be summer. S-U-M-M-E-R. Summer. S-U-M-M-E-R. All right, so here's our next problem. So for our next problem, let's do 4 times 5 and 2/10. So the first thing we are going to do is we are going to pull apart that 5 and 2/10. So we're going to have 4 times 5 plus 2/10. And remember, it's really important to have those parentheses. Makes a huge difference when you're doing math where your parentheses are. All right, so now I am going to go ahead and I am going to distribute that 4. Sorry about all the noise. I'm going to distribute that. Oh my goodness. I'm going to pause for a second. All right, and we're back. So I'm going to distribute that 4 across this entire thing. So I'm going to do 4 times 5 and 4 times 2/10. All right, so let's write that. Let's show that. So when I show that, I'm going to have 4 times 5. So that's this first part. Plus, the plus comes from right there, 4 times 2/10. And again, we're just using the distributive property. Sorry, I didn't write that better. All right, so this is nice and easy. 4 times 5 is just 20. And now is where you have to decide which way you want to do this. Let me make this look a little bit more timesy. There we go. So I have a couple different ways that I can do this. Hold on, guys. Sorry about that. All right, so let's think about the 2 different ways that we're really focusing on doing this. So if I have, one way, remember, is 4 times 2/10. One way I could choose to do this is just to simply right away say I have 4 times 2 divided by 10. And you would get 8/10. So that's one way that you could do that. The other way that you could do that is that you could go ahead and say that you have 4, we'll write it again, times 2/10. And I could say that I have 4 wholes times 2/10. So I have 4 ones or 4 wholes times 2/10. And I end up with 8/10. I'm so sorry. Someone keeps going by and the puppy keeps getting distracted and running over there. Either way, you're going to get the same thing. So I'm going to go ahead and write, I'm going to do it this way for now. Puppy. So what I end up with, again, is going to be 4 times 2 over 10. And I just chose this way. You could do either one. For the next problem, I'll do it that way. So then I end up with 20 plus, and 4 times 2 is 8 tenths. So we have 4 times 2 over 10. We brought it here. Now we're here. And then we just have to put this together. And what we end up with is 20 and 8 tenths as our answer. Okay, let's do another one. I don't know if I have enough room here. I'm going to give it a go and see if I can squeeze it in. I'd rather not waste more paper than I already am. Okay, so our next problem is going to be, what did I write down for us? Oh, here's one. We're going to do 3 times 7 3/4. All right, so to do this one, again, let's first pull this apart. So let's rewrite this. So we're going to have 3 times 7 plus 3/4. And all I did was I pulled apart my mixed number. So I decomposed it into 7 plus 3/4. And now what we want to do is we want to distribute that 3 across. So we're going to do 3 times 7 and 3 times 3/4. So I'm going to go ahead and write that. So 3 times 7. We keep our plus. We're still adding these two. 3 times 3/4. And now I can do my multiplication. So here we have 3 times 7 is 21 plus, and for this one I'm going to do it that other way, where I'm going to do 3 over 1 times 3/4. And again, you have to show your parentheses. So either way, I'm going to end up with here 21 plus 9/4. Now you could have done it the other way. I'm going to show it right here. So instead I could have had 3 times 3/4, and I could have just straight away said 3 times 3 divided by 4. Whichever way you're better with is fine. You're going to get the same answer. Okay, and then you would rejoin over here. So those are your two options for doing this. So let me put all this together, but I have a problem. If I put this all together, I have a fraction greater than 1. We don't like to leave our fractions greater than 1 like that. So what we have to do is turn that into a mixed number. So to turn that into a mixed number, our rule for this problem, remember how we always find a rule for problems, and it's based on the denominator. Our rule for this problem has to do with the fact that we have fourths in our denominator. So we know that 4/4 is equal to 1. What we want to do is we want to pull out groups of 4/4 from this so that we no longer have a fraction greater than 1. So I can pull out 4/4. So I had 9. I put 4 here. I can put another 4 here. So that's 4, 8. So that means I have one more fourth. And you can see 4 plus 4 plus 1 is 9. So I was able to pull 9/4 out. And this altogether becomes 2 wholes, because this is 1 and this is 1. We know that from our rule. So this is 1, 2, and a 4th. So now what I have to do is I need to add, I'm going to bring down my 21. I still have that. I need to add my 21 plus 2 and a 4th. I'm just going to go over this so that it really pops more. So now I'm going to add those together, and I end up 21 plus 2 is 23, and I have a 4th still. And that's our answer for that one. So I'm going to give you our next secret word, which is is, is. So 23 and a 4th is our answer. Let's go ahead and let's jump into the problem set, and we'll do a couple of those. But this is the lesson, so we have 2 really nice, easy lessons. Who would have thought that multiplying fractions was going to be so much easier than adding and subtracting them? All right, so let's take a look at this one. So for the first problem, it says draw tape diagrams to show 2 ways to represent 2 units of 4 2/3. So when they're saying that we're representing 2 units of 4 2/3, what they're really saying is 2 times 4 2/3. They're saying 4 2/3 2 times. So let's go ahead and let's draw that. And hold on, I'm just kind of shifting my stuff around. I'm looking for some of my papers that I have here. Give me one sec. All right, so this is what we did in the very beginning, where we would first show it 4 2/3 2 times, and then we would kind of shift things around. So let's go ahead and do that. So 4 2/3. So I'm going to first have a nice long 4, so that represents 4 wholes. And then what I'm going to do is I'm going to go ahead and model the 2/3 separately. I'm going to say that that's 2/3. So now I have 4 2/3 one time. And now I'm going to do it again. And then I'm actually going to model it a whole separate way for you after we're done with this. I want to show you something else we could have done. So here I have 4, and I'm going to show our 2/3 right here. So that's 4 2/3 2 times. We have it here one time, and then we have it a second time. And now what we want to do is we want to move things around so that we have our whole numbers together and our fractions together. So we're going to do 4 2 times, and we're going to do 2/3 2 times. Do you hear what that sounds like when I say that we're going to do 4 2 times and we're going to do 2/3 2 times? I hope that you're kind of seeing that. Sorry, this times is really not great. All right, so let's go ahead and model that. So to do that, I'm going to do the same thing first. I'm going to have my 4. And then I'm going to put this 4 next to it. So now I have my 2 4s. I have 4 2 times. And then I'm going to put my 2/3 once, so that's this 2/3. And then I'm going to go ahead and put that 2/3. So I have 4 2 times, 4 2 times, and I have 2/3 2 times, 2/3 2 times. So that's modeling this. And wow, those are really awful drawings. I just want to show you one other way that I could have done this, but I think that this is more clear. You might sometimes see someone do it like this the first time, where they go and they write 4 2/3, and then they do it again, and they write 4 2/3. And that's fine, but I don't think that that really models what we're doing as well, so I don't want to do it that way. I really want you to focus on doing it this way. I think that's going to be a better way of doing it because we're already pulling everything apart. But I just want you to know that this is a way that you might see someone do it somewhere. All right, so then it says, write a multiplication expression to match your tape diagram. And we already have that right there. We have 2 times 4 2/3 or 4 2/3 2 times. So 2 times 4 2/3. And that's fine. You didn't have to go ahead and distribute it or anything like that. Okay, so now for number 2, it says, solve the following using the distributive property. The first one has been done for you. So you can see here it also says that you may omit the step that is in line 2, and they're talking about this, that you don't have to do this. For today, I'm going to ask you guys to continue modeling this out, but what they're saying is that you could have just in your head said 3 times 6 is 18 and 3 times 4/5. Well, let me say this. I'll show you a way that you can omit it if you want. I am going to give you a shortcut, but I do want an intermittent, a middle step there. Ooh. Just had a clover fall out of my hair that my daughter put there. They're beautiful and they smell delicious. Okay, so let's do this one together. So again, the first step is to show us pulling apart or decomposing 4 2/3. So we're going to have 2 times, but we still have to show that it's one piece. 4 plus 2/3. And now what we're going to do is we're going to do the distributive property. So we're going to show ourselves distributing this 2 times, and we're going to distribute it across the 4 and the 2/3. So we're going to do 2 times 4 and 2 times 2/3, and we have to add those together. So I'm going to show that by doing 2 times 4, you have to put those in parentheses, plus 2 times 2/3. And now what I'm going to go ahead and do is I'm going to do the multiplication. So I'm going to do 2 times 4 is 8, plus, and then you can do this whichever way you want. You can do 2 times 2 over 3, and I'll jot that up here. You could do 2 times 2 over 3, or the other way that we were doing this is to say that you have 2 over 1 times 2/3. Either way, ooh, I didn't do a great job keeping that in frame, sorry. So either way, whichever way you do it, you're going to get 4/3. 2 times 2 is 4/3. So I'm going to go ahead and write that, 4/3. And then we have to, go ahead and realize that this 4/3 can be converted into a mixed number. And what you're going to get is, we're going to do 3/3 here and 1/3 here, because 4/3 is the same as 3/3 and 1/3. This becomes 1 1/3, and we still have our 8 plus that, so that still exists. So we have 8 plus 1 is 9 1/3. Now, what I do want to show you is the shortcut that you can use. So if you don't want to do this step right here, I'm okay with that. What you could have done, and let me do it in a different color. So I'm going to pick it up from right here, where you have 2 times 4 2/3. Ooh, there we go. So I am okay. I don't want you to just totally jump to this step like they have here, so I don't want you to just totally jump down here. I'm okay with you saying, oh, well, I know the first one is 2 times 4 is 8, plus, but then I would like you to still model out that you're doing 2 times the 2 over there, so 2 times 2/3. So it's still like something like this modeled out for me, so that I can see what you did. And then you'd have 8 plus 4/3. And then you'd have to go through all the other steps that we just did right there, and you'd end up with 9 1/3. Maybe I'm going to recant that. I'm going to say just for problem 2, I would like to still see the steps, but by problem 3, it's fine if you skip it, and you can just skip ahead and write your answers. So for part of your classwork that you're going to do, problems C and D from this one. And then let's go ahead. So how about we say this? Sorry guys, I know I'm being confusing. For these two, go ahead and I want to see all the steps, and then for these, you can skip the steps. So I think that's a fair way of doing it. And then I do want you guys to go ahead and try this, where you're going to be doing the word problem. We haven't done a lot of word problems with these, but I do want you guys to get comfortable with them, so they are going to be part of the problem of the days that we're working on. So you're going to see your word problems there. All right, so that is it. I hope that everyone's doing well, and I will see you in our Google Classroom. And I do have to give you that final code, and I almost accidentally just said it. So the final piece of our code is CLOSE, C-L-O-S-E, exclamation point, close, C-L-O-S-E. So I hope you have that complete code because you watched through the video. It's a pretty short video, under 23 minutes if I can say goodbye quickly enough. So I hope everyone has a great day, and I'll see you in our Google Classroom.